All right. So, everybody out there in YouTube land and in Facebook land and in, I think, LinkedIn land, I should be streaming right now. So, welcome. It is, you know what today is? Today is Friday. I thought yesterday was Friday. I thought the day before was Friday. I lost track of the days, and then I realized that no, it wasn't Friday. So I am back in the saddle here for another Q&A Friday. I had told you guys and gals out there that I would do this week, and I am. So just want to make sure that everybody knows that we are back to Q&As, and I'm getting ready for the holidays, as I know you are ready for Christmas. If you celebrate Christmas, if you're, I know the Greek Orthodox Christmas is, I think, a week or two after. Anyway, this is the holiday season. Hey, Niha, that's right. You're over there in Hawaii, aren't you? Aloha. And you're behind by what? I don't know how many hours you're behind me, but it's 12 o'clock Eastern. What time is it in Hawaii, my friend? Is it 9 o'clock a.m.? Hey, and I got a shout out to the Central Texas section in Austin. Thanks for the coffee mugs from our presentation. Oh, there it is. Cire Beltran. Don't tell me you both are out there in Hawaii. Come on, 7 a.m. Honolulu. Wow. Well, have fun out there. I know you will, but just remember to have fun. And C-Ray, don't let him get you in trouble if you're out there too. All right, so I don't know if my audio just changed, but I'm coming off my cell phone now. All right, geez. Okay, all right, say hi to everybody at the IAS board meeting. I think you probably will see Dave DeRocher out there, I don't know. All right, so today is Q&A Friday, and I wanted to go through a few questions. And I got my code book out. Hopefully you got your code book. And if you don't have a code book, hopefully you have, hey, Steve Fromy. Yes, Steve, we need some snow. And I think we're supposed to get some snow. We had some spitting going on out there. It was like little bits of ice. So we have some snow going on, or I think we're going to get some in here. Oh, Hickam Air Base. Excellent. Pearl Harbor. Well, C-Ray, Beltran, don't have too much fun out there. And you're in beautiful weather. So it's cold outside, it's wet outside, and hopefully it will be snowing soon. All right, so let's take a look at some questions. I'm going to go back over to home. I got to go to YouTube Studio, and I got to go to comments, and I am going to scroll down through here. I have my code book. I'm going to try to find where we were last. Oh, Dave Durog, Weijin and Dilip are here. Oh, say hi to Weijin Lee and to Dilip. Give Dilip a big hug for me. All right, so here we go. Gentlemen, you're doing an outstanding job. This was the IEEE PCIC. Remember, Nihan, when we were there? And remember, we talked about application engineers, and Furman Minori said he's an application engineer at Eaton, and he couldn't agree more because we were talking about how important application engineers are from all these organizations. All right, sorry I missed it from on the road. Union Station looks good. What happens? Okay, so I remember we talked about what happens if the fault current exceeds the rating of the circuit breaker. So that was an unintended rapid disassembly in the field. If you don't recall from was it last Friday? Anyway, All right. In case of fault current, okay, so here we go. Let's see if you haven't changed them. Okay, here we go. We already talked about the per unit when you have the motor at a different voltage and the impedance at a different voltage. Talked about that last week. All right, there's, okay, I can hear you, Tom. Really appreciate a lot of people saying thank you and great job, so we appreciate that. And Willie Snyder looks like he's going to try to delete 210.8F and add HVAC equipment to 210.8D. Oh, Willie Snyder. All right. Carlos, good to see you. Buckeye, Arizona. Excellent. All right, so Willie Snyder had a comment. 210.8F. I need to put a placeholder here. Put my Cogburn Brothers Electric white red tab here. 210.8F. Let's read 210.8F, because that's getting a lot of attention lately. So 210.8 is ground fault circuit interrupter protection. We know that. F is outdoor outlets. Now, it says that, and it applies to dwelling units, and it applies to dwelling unit outdoor outlets. Now, when we say outlets, we mean anything that is hardwired. So it doesn't have to be a receptacle. Then it doesn't have to be a cord and plug piece of equipment, because receptacles are already covered under 210.8A for dwelling units. Outdoor receptacles have to have GFCI protection. But here in 210.8F, it simply says an outlet. It doesn't say receptacle outlet. So it's anything that's outside and cord and plug and hardwired. Now, there is an exception. There is one actually there's two exceptions. But it says, in addition, from a dwelling unit perspective, it also speaks to the outlets located in garages that have floors located at or below grade level. It speaks to accessory buildings and boathouses. So in addition to all outdoor outlets at a dwelling unit, it also picks up the garages, accessory buildings, and boathouses. Now, Mr. Snyder says he's going to delete 210, he's going to suggest to delete 210.8F and add HVAC equipment to 210.8D, which is specific appliances. Now, the reason, I wouldn't have a problem adding HVAC equipment to D. That might be a good move because it is an appliance, and that would cover whether it's hardwired or cord and plug connected. But the problem that I would have with deleting 210.8F is, and I think there's a misconception. I think a lot of people assume that the only thing you're picking up in 210.8F for outdoor outlets is HVAC equipment. That's the most prevalent piece of equipment that you might see on the outside of a residential dwelling unit. But there are other outlets. There are other things that might be out there. If you have a car charger, that would have to be GFCI protected because it would be hardwired. If it was a hardwired car charger that was on the outside of the house, that would have to be GFCI protected. If you have a sump pump on the outside of the house, that would have to be GFCI protected. Or not a sump pump, but a well water, a well pump, or septic. I know in my house, my previous house, the one that I sold, we had a sand mound system, and there were a couple pumps outside. I had GFCI protected everything. So I had GFCI going outside of the house as well, and those were not, there's not cord and plug connected, that was actually hardwired. So that's what would be picked up. And that's exactly right, Nihad. It's much more generic than just HVAC equipment. So I do think that it has merit to say, let's put, now the other thing I think, I don't have my pen. The other thing I think we need to do is look at the title of D. It says specific appliances, and it's really branch circuits supplying specific appliances. It's not on the appliance. So it's for the branch circuit. These requirements in D apply to the branch circuit, not the appliance. And I think that's a misconception some people have. They think that look, you have an appliance requirement in 210.8, which is in 210, which is branch circuits, and that's not what this is. If you think about GFCI in any receptacle in a kitchen, like in my kitchen here, any of these receptacles, the GFCI that is protecting those receptacles, which is in my panel board, is not there for the receptacle. The receptacle is not the hazard. It's there for any appliance that is plugged in to those receptacles, whether it be a toaster, mixer, deep fryers, any of those would have to, that's what that GFCI is there for. It's not because the receptacle is dangerous. It's because what I'm plugging into the receptacle can be. If it's abused, if you use everything per its listing and you use everything correctly, if you read the instructions on everything, and if you perform proper maintenance on everything, you don't need GFCI. But it's there for when things go wrong. And that's going to be whatever is plugged in, which is going to be an appliance. So in any case, we could clean up some of the language. Like it says crawl space lighting outlets. We could say branch circuits serving crawl space lighting outlets. Branch circuits serving specific appliances. Branch circuits in other than dwelling units. So I guess, and then the other part of me is saying it's a given because it's in branch circuits. That's what it applies to. Anyway, forget about it. So Willie, I like your idea, but I don't think you'd have justification for deleting 210.8F because you're moving that over there. You'd have to justify why all of those other solutions that would be hardwired outside of the structure should not be afforded GFCI. All right, so let's move on. Moving on up. Why do we need to size up the breaker? This is on fire pumps. Fire pumps is chapter 6, and I believe it's 695, 690 something. Fire pumps. Yep, 695 fire pumps. So this was on our fire pumps presentation. Jesse Santos, why do we need to size up the breaker to locked rotor current, though the fire pump controller is not required? Though the fire pump controller is not required. We do not want to trip the breaker during overload, but the overcurrent protection at the fire pump controller would trip. Well, I'm not sure if I understand exactly that question, and I'm not sure if it's. I'm going to try. Let's do this. If we go to B, connection through disconnecting means and overcurrent. So this is in 695.4, continuity of power, and B, connection through disconnecting means and overcurrent device. B1 is the number of disconnects, so this tells you how many disconnects you need. B2 is your overcurrent protected device selection, and he's talking about why do we need to size up the breaker? So he's talking about overcurrent protection. I think it would be hard to make that change. After 6 years, HVAC manufacturers are still fighting 210.8F. Yeah, I know, Nihad. I know, it's frustrating, but anyway, but we're getting somewhere because before, here's my point, here's my thought on that. So Nihad, you brought up a point. So, and if anybody out there who's not aware, there are some HVAC equipment, usually those with high frequency. Now there's claims that there are standard HVAC units, not the high efficiency ones, that are using the equipment grounding conductor, which violates Article 250. there are claims that they are using the equipment grounding conductor for current return. And which is interesting that some manufacturers are saying that they're using it. I mean, they're admitting they're violating the Article 250. But in any case, there was no policing in the standards. But the fact that we are sitting at a table talking about this problem and trying to come up with a solution is a good thing. If this would have happened, Nihad, 10, 15 years ago, this would all be behind us right now. But the fact is that we increased the current rating on what needs to be GFCI protected and the voltage. We've increased the circuits. And now we're identifying equipment where there is statistics of death. Whether or not those deaths are directly due to that leakage current, I can't answer that question. But regardless, the compatibility concern is there, and we're on the road to fixing it. So, all right, so why do we need to size up the breaker? Let's go back to this, 695. Overcurrent devices shall comply with 695.4 B2A or B2B. B2A is your individual sources. And this is saying that the overcurrent device shall be rated to carry indefinitely the sum of the locked rotor currents of the largest fire pump motor and the full load current of all the other pump motors and accessory equipment, where the locked rotor current doesn't correspond to a standard. So then, okay, so you can go to the next higher. And it says the requirement to carry the locked rotor currents indefinitely shall not apply to conductors or devices other than overcurrent devices in the fire pump motor circuits. I think I know what you're saying. The requirement to carry the locked rotor currents indefinitely shall not apply to conductors or devices other than overcurrent devices in the fire pump, other than fire. Okay, so you still need to. It's in the fire pump controller, and you're saying that we do not want to trip the breaker during overload, but the overcurrent protection at the fire pump controller would trip. And 2 says, wait a second though. All right, so I think I get what he's saying. So here's the thing, all right. Here's the thing, Jesse, you've got to look at, in my opinion, this is my opinion. 695.4B1 tells us the number of disconnecting means. So it says a single disconnecting means and associated overcurrent protective devices, a single, shall be permitted to be installed between the fire pump sources and one of the following. Between the fire pump sources and one of the following. Between the fire pump source and a listed fire pump controller, the fire pump source and a listed fire pump power transfer switch, I think I see what you're saying. So his point is, that because the language, the requirement to carry the locked rotor current indefinitely shall not apply to conductors or devices other than overcurrent devices in the fire pump motor controller. So if I have a circuit breaker ahead of the fire pump motor circuit, not the controller, fire pump motor circuit. So the fire pump motor circuit is not in the controller. So it doesn't say the controller, it says the fire pump motor circuit. So if you're outside of the fire pump motor circuit, it doesn't apply. And if I have a circuit breaker upstream and it's feeding the controller and there's one in the controller, then they both have to comply with this. So I know, okay, I'm back to not understanding the question. I almost thought I saw what you were talking about, but I would argue that your overcurrent devices have to let locked rotor current flow regardless if they're in the motor circuit. and you're only there for overload protection. So I don't necessarily understand your perspective, Jesse, that the overcurrent protection at the fire pump controller would trip. Because if it was at the fire pump controller, I think you still have to follow 695.4B2. And it has to be greater than the locked rotor amps. And then there's a 695.3C. And then there's an H, overcurrent device selection. An instantaneous trip circuit breaker shall be permitted in lieu of the overcurrent devices, provided that as part of the transfer switch assembly listed for fire pump service that complies with 695.4B2A2. 695.4B2, which is the overcurrent device, which we just said, A, which is individual sources, and 2, overcurrent protection has to be provided by an assembly listed for fire pump services and comply with the following. The overcurrent device shall not open within 2 minutes at 600%. The overcurrent device shall not open with a restart transient at 24 times the full load current of the fire pump motors, and the overcurrent device shall not open within 10 minutes at 300%, and the trip point for the circuit breaker shall not be field adjustable. So this covers, I believe, all of those issues that I think you're having concern with. So my suggestion would be, Jesse, take a look at 695.3D, 695.3A, and 695.4A and B. I believe you're covered with that instantaneous. So that's the only thing I would say, Jesse. So hopefully, I'd love to hear you come back with that. If you have any other questions on that, please, you can send them to my Gmail account, tdomitrovich@gmail.com. So T, my last name, Domitrovich, DOMITROV as in Victor, ICH, at gmail.com. All right, moving on up. Michael Anthony, good to see you too. At Detroit. All right, wire gauge. So this is that 75 kVA transformer. I'm telling you, that's one of my most watched presentations, videos, is when we were picking the primary and secondary overcurrent devices for the 75 kVA transformer. And this gentleman says, I just put in a 75 kVA transformer and panel board. It was a great tech talk. Excellent. Richard Parker. And then Daniel Nava. Daniel says, what gauge wire did you use for the high and low voltage? All right, so I never put that in. So let's do this. Let me show you something. Let us do this. All right, got the audio back. Sorry about that. All right, Jeff Bauer, Daryl Hill, we're back. Let's go back to our, let's go back to this. Now I have to do the 75 kVA transform. I'm going to talk about this again. Sorry about that. I hope I'm not double dipping on this one. You know what will happen is I know when I go back to here, I'm going to have double. So I got to shut that one down. There we go. All right. I was having some audio issues. All right, so we're back here. So I got a 75 kVA transformer, 480 to 208. I said I'm not going to worry about the percent impedance because my percent impedance is the only reason I would want to know the percent impedance is for available fault current on the secondary. So when I'm picking my primary and secondary overcurrent devices, outside of what the interrupting ratings are, I'm going to be starting with the full load amps. So I can't remember what I ended up, but let's talk about the secondary. 450 is going to tell me my largest secondary overcurrent protective device. So I go to my tables, and primary and secondary protection, my secondary protection can't be more than 125%. So my secondary full load amps, 75 divided by square root of 3 divided by 0.208, 75 kVA, 3 square root divide 0.208 divide 208.2, 208.2. So equals 208.2 amps. So secondary OCPD, and I always say pick the OCPD first, right? Because how are we going to pick an overcurrent protective device? If it's going to be the main in a panel board, I have to know what panel boards I can pick that I can put a main in. So if my maximum size is 1.25 times 208, and I can go to the next higher, 1.25, I'm going to multiply this number by 1.25 times 260. And if I go to, I'm allowed to go to the next higher, 260, I'm going to go to 240. Article 240 has a nice little table of the standard ampere ratings, 240.6. I'm at 260. That means I can go to 300 amps. Now, can I get a 300 amp panel board? I don't know. 300 amp panel boards. So let's do this. You're going to love this. I'm going to use my thing here. I'm going to go to Eaton panel boards, because I mean, why would you buy anything else other than Eaton panel boards, right? I mean, is there another manufacturer out there? Not. I'm just saying. All right. I mean, come on. I mean, so on a 300 amp panel board, I'm going to go for a breaker panel board first. And this is a 208. So I'm going to go to a 2X, a double X. Let's check the shirt. All right, so I am going to go to resources. Oh, wait. I'll go to technical. All right, so here we go. Ratings. Continuous current from 100 to 600 amps. This is what I'm going to do. I'm just going to open up my... hopefully, man, for some reason it's taking time. You know what? I'm going to get rid of some of these. Get rid of that. I'm going to get rid of that. I'm going to get rid of NFPA link. That one, and that one. All right, so here we go. Catalogs, panel boards. All right, so we were going to look at Powerline 2X. Here we go. Here's my main breakers. I can go from 100 amp, 225, 400, 600. Now I could get a 400 amp electronic trip unit and down it down, or I can just say it's a 225 amp panel board. So those are the main breakers that I have available. Main lug only, which I would never do a main lug only on the secondary of a transformer. Why? Because it's not permitted. Delta Y ground, can't do it. Got to land on an overcurrent device. So I'm going to say it's a 225 amp panel board for giggles. 225 amp panel board. So what is the what's the conductor that I need? I need at least 225 amps of conductor. So then I go to 310.16 and I say I'm going to go to a 225 amp panel board. Right? So let's do this. And we'll say this is 225 amps. I need 225 amps worth of conductor. I go to 310.16. And you guys and gals out there probably know this even better than I do. 75 degrees C because I'm landing on an overcurrent, because I'm going into equipment that's rated 75 degrees C. 225 amps, I could go with a 4-aught conductor. I could do a 4-aught. A 4-aught conductor is 230 amps. If I wanted to do what did I say, 225? I could do, wow, I could do 2. I could do 4. I can do, that would be quantity 1. Quantity of 1. Or I can do number 2, a 2 AWG. And that would be 230 amps. And quantity of 2. So whatever you got on the truck, right? As long as it is 230 amps. Now, okay, so the other thing is if I do 2, then that's 2 per phase. Now I got to think about adjustments. I might not be able to do that. I would go to a 4-aught, right? I would go to a single 4-aught. That would be 3 plus 1 neutral plus an EGC. The neutral shouldn't be carrying current, so I don't have to count it as a current carrying conductor. But if I have unbalanced loads and I meet those rules, then I might have to. I don't count the EGC, so three conductors, and then I go to the number of conductors. 4 to 6 is 80%. I don't have to follow that because it's adjustment factors for more than 3 current carrying conductors. If my neutral is not a current carrying conductor, then I don't have to count it. But if I have unbalanced loads enough to a point where I have to call it a current carrying conductor because I know current's going to come back over that neutral, then I would call that a 4, and I would have to go to 80% and adjust my ampacity appropriately. 230 times 0.8. That's 184. I could not do, I would have to add another one if I have to call that a current carrying conductor. Make sense? But Daryl, does Mr. Hill, am I smoking some weed from the motherland or what? Jeff Bauer, what do you think? Would you put a 4-aught conductor on the secondary? Now let's talk about primary. So that's secondary. What about primary? Primary, full load amps, 75 divided by square root of 3, divide that by 0.480, $75, 3 square root, divide 0.48, divide 90.2 amps. So 90.2 amps. If I put it 125%, I would take 1.25 times 90.2, and what is that? 1.25 times 112. So I could put Say that's 112. What would I go? I go up, let's go back to Article 240. See what's my overcurrent protected device. What's some standard ampere ratings? 112. I can go to a 125 amp break, 150 amp breaker. So I could put a 125 in there. Let's go to 125 amp breakers. So Eaton, MCCB, molded case circuit breakers by Eaton, because there is no other manufacturer. Look at that lineup we got going on here. I mean, why would you go anywhere else? There is no other place to go. Eaton circuit breakers, power defense, molded case circuit breakers, power defense, baby. Defending the, look at that. Isn't that beautiful? I mean, just look at that. Wow. It's unbelievable. It's absolutely brings a tear to you, doesn't it? All right, so let's look at catalogs, molded case circuit breakers. What breaker would I use? And okay, so, and I talked about this before. Yeah, 225 amp can only take one conductor per phase, so I would do the 4-aught. Thank you, Alan. So 4-aught conductor, that's what I would do on the secondary. Yep, and now we have to look at what was the breaker size on the secondary? 112. We were talking about anything greater than 112, right? Because that's only at 125%. Remember, I can go up to 250. So 1.25 divide. So at 90.2, I can 250, 2.5. I can go up to a 225 amp breaker. I can't go greater than 225.5. I can go at 225 or less. So I can't go to the next higher because 250% is the maximum size based on the tables, right? So current, yep, 250%. There's a note 3. I can't go any higher than that. So that's an important thing to remember. All right. So 112, let's go back to the website. And there's your 225s. There they are. The doggies are back. How do you do? They left it in?
Yeah, still drank, so keep it.
Well, Jakey has a, he's got to keep the drawing on. Dadgummit. All right, so I would probably go to a, what was that? Let's take a look at what we have it in. So we're at 480 volts. Those are the interrupting ratings. Here we go. F frame. Continuous current ratings. 125, 110. So 125 amp breaker. I could put that, and it depends on the panel board that I have upstream. And I covered that, I think it was last week or this week sometime. It's important to recognize that when you're selecting an overcurrent protective device, you've got to think about what is the panel board or switch board that you're going to put it in. You just can't pick any circuit breaker. So if we go back to the circuit breaker panels, this will tell you which ones you can put those breakers in. Right, so this is your, power line expert, main fuses, or, so this is a fuse. So let's go back up. Oh, this is my series ratings tables. Go back up to the top and say we pick a power line 2X, right? This will tell me what breakers can be in the main position. So a power line 2X is 480, 277, and I have 125 amp. Remember, I have a 125 amp feeder going to the transformer. So my upstream panel board cannot be power line 2X because look, this is your branch circuit breakers, I can't go higher than 100 amps. So I'm not going to be, for an upstream panel board, I'm not going to be in a Powerline 2X. What am I going to be in? I am going to probably be in a Powerline, let's try a 3X. Powerline 3X. There is my main lug only. There's my main breakers. Here are my branch breakers. So I can go up to a 200 amp right here with a PDG2 plus P. So I can go up to 225 right here. So 110 to 225, 200,000 amp interrupting rating. So I can go to 225, 225. So I could put that Powerline Expert panel board upstream. So you see what I'm saying? You have to pick what is what's the equipment that you have. I don't know how do you get, there it is. So I'm going to click the very top. Now let's go to a Powerline, now a Powerline 4X. You know, there's your main breakers. And I mean, look at the options that you have with regard to any of the branches. So that Powerline 4X is going to be the cure-all for everything. So my recommendation would be to pick a breaker, pick the panel, pick the equipment that you're going to put up there or you want to put there, and then make sure that the overcurrent protected device that you pick will fit in that panel. So what do we say? So if we are at if the highest I can go on the primary is 225 and my 112 amps is 1.25, I could put a 150 amp breaker there, or you know, I could put a 175, I could put a 200. What would govern why I would pick? I would probably want to pick the smallest breaker I could. That would give me the lowest cost. So if I did 125 amps, if I did 125 amps on the primary, I'd need 125 amps worth of conductor, and then I go to 310. I go to 310. 310.16. 125 amps, we got to use the 75 degrees C because I'm going to be coming out of a piece of equipment upstream that's 75 degrees C. And if I need 125, I could use a number one. I can use one American wire gauge right there. That'll give me 130 amps. Now that'll be 3 conductors, no neutral because it is a delta primary and an equipment grounding conductor. So 3 conductors. I'd use a 1 gauge. A 1 gauge. I mean, you can use a 1/0 if that's what you got on the truck. Still put the same, the overcurrent protected device, 125 amps, because a 1/0 will get you a 150 amps. So, and that might even give you some breathing room in case you have to put a larger breaker in for whatever reason. And if I went to 250%, what was 250%? 225 amps. If I had to do 225 amps, I'd probably put a 4/0 on the primary. So a 4/0 and a 4/0. That's, but I'd probably go with 130 amps. So you just gotta, once you pick the overcurrent protection for primary and secondary that gets you what you need, and you'll pick your breakers based upon the equipment you can put upstream and the equipment that you're going to feed. And then you pick your conductors and you do your, oh yeah, Alan, you're right. You can do a sub-feeder breaker. So what he's talking about there, beautiful, Alan, in a Powerline 2X. So let's go back to the Powerline 2X. Very good point. He is 100% right. Go back to that Powerline 2X because what are we trying to do? We want to use that, your goal from a cost-effective perspective, from a financial perspective, you want to use the smallest piece of steel you can use upstream. Now, it may not help you in the future when you expand, but at least on the initial job, it'll get your cost down. You have the Powerline 2X, you have your main lug only, you have your main breaker, and then you have a branch circuit breakers. And if the feed through, so what the way they do a feed through, let's just talk about a feed through. What do we mean by that? So if I draw a panel board, okay, I've got a panel board like this. I'll have a main over, whoa. I'll have a main overcurrent, wow, dadgummit. A main overcurrent protected device coming in, right? I have my branch breakers going out. And then down here at the bottom, we could, all right, Jeff, get back to work, brother. We could put a breaker down here feeding our transformer. This is a feed through. Sub feed breaker. I sometimes refer to those as feed through. And here's the other funny part. If this breaker, so let's do this. If what was our number? The primary, we said 130 amps, right? So let's say this is a 225 amp main. Okay, 225 amp main. And that was the maximum, right? That was our maximum size was 225 amps. If that was a 225 amp main, I could just do that. And don't put an overcurrent protected device, because this now provides me my protection for that transformer, because that 225 amp breaker is protecting the panel and all of its loads, which this is one of its loads. And as long as that is 225 amps worth of conductor, I can get that done. So what does that mean? Now, what you'd have to do is weigh that with, now, here's the other problem that you have. I can't disconnect that transformer without shutting down the old panel. It's probably not a good idea. Probably not a good idea. So let's take that one off the shelf. We came up with the idea and then we threw away the idea. So if I have basically a breaker here and a conductor there, and we said that was 130 amps, 130 amps, and this is 130 amps worth of conductor, which we said could be a number 2. Yeah, that could be a 2. A 2 AWG. We'll get you 100. No, that's 90 degrees C. A 1. A 1 AWG. See, it helps to read the right column or the center column for 75 degrees C. So a 1 gauge will get you 130 amps worth of conductor. Put that on a 130 amp breaker. And you are Kovacevic, if I can get a 130 amp breaker. Not 130 amp, so I can do 150 amp. Let's go back to our conductors again. Put a 1-aught in there. Make this 150. I'd feel more comfortable with that. A 1-aught, 150 amps worth of conductor. I think that smells better, don't you? What do you think, Jeff? Or Alan? Jeff's gone. Alan, I think that might be a little bit better. Put a 150 amp sub-feed breaker in that panel. And then you'd have to find, now we'd have to go back. I don't know if it might, you might have to look at what we call bid manager to see if I can put that in there. Because I don't see, I see branch, but I don't see the provisions for a feed through on this panel board. There's your panel board types, width, depth. And there's your main breaker types, horizontal and vertical. And then you're to a Powerline 2XF. So, and that's your fusible. So, if I can do a subfeed through this, then that would be the way to do it. So anyway, that's what I would do. Make sense? I don't know why that says 941 when it is 1251. All right. Let's go back to here. And I do not have dual, so we're good. All right, so that is how I would do that. That's how I would do that, because that's what we do. All right, what gauge? We talked about the fire pump. And, oh, one last question that we had. So I had this question yesterday, I think it was. Yeah, it was yesterday. Surge receptacles. So we make receptacles that have built-in surge protection. Receptacle, surge Eaton. And why would you pick a Eaton surge receptacle? Because there is no other. I mean, here we go. Look at this, surge receptacles. So there's what they basically look like. They have the surge built into it. Now, here was the question, right? The question was, if I have a 15 amp receptacle with built-in surge protection, can I put it on a 20 amp circuit? Now, these receptacles are listed to two different standards. One is UL 1449 for surges, and the other is 498. So the receptacle itself is listed to UL 498. The surge protected device, the surge that's in that receptacle, is listed to UL 1449. The product, if you think about the way surge is made, a surge product is looking at voltage, and it's looking at voltage transients. You put the MOV across the terminals or the protected circuit, and then it will clamp that voltage. So it's typically in parallel with the circuit. You're not in series. If you have a 15 amp or a 20 amp receptacle, you would follow the rules of receptacle, what can be fed from a receptacle perspective and what you can put on which branch circuit and their ratings based upon the requirements found in 210. So in Article 210, which covers receptacles, and I believe it's 210.21, tells you, maximum cord and plug connected load, receptacle ratings for circuits serving more than one receptacle or receptacle outlet. So 210.21B3 tells you that if you have more than one receptacle outlet, which, if you think about strings, it's as long as it's not a dedicated circuit, you have a surge protection on there, you can put a 15 or 20 amp receptacle on a 20 amp branch circuit. So that's not a problem. And the surge device is not going to cause you an issue. You don't have to protect the surge at a 15 amps because it's in a 15 amp receptacle. You can use that 15 amp receptacle just as you would in any other receptacle. Put as many as you want. Put those on branch circuits rated 215 or 220. I love it. Where are you going? You heading out?
Yeah.
Okay. Coming back? Excellent. All right. So both of those standards are covered, and you don't have to worry about how many. You just follow the rules in 210.21. Table 210.21b3. So in 210.21b is your single receptacle. 210.21b3 is your receptacle ratings where connected to a branch circuit supplying 2 or more receptacles. You have the table 210.21b3 that tells you how many you can put on it. Don't worry about if you have a 15 amp receptacle and you have it on a 20 amp branch circuit. If you're following the rules in the code for receptacles, you're good to go. All right. And that's all I have to say about that. All right. So Q&A Friday. We did an hour. Hopefully you got something out of our time together. We covered a few questions. I think we're golden. So that's all I got for today. Hopefully you're going to have a good weekend, and I will probably see now. I will go live next Friday, I believe. I'm going to do another Q&A Friday. So if you have any questions, send them in to tdimitrovich@gmail.com. Send me an email. And I'll see what I can do to answer them. And then what else? I'll be recording some videos next week, over the next couple weeks, over my holidays here. And we'll be talking 2023 code changes. So tune in. If you haven't subscribed, don't forget to subscribe and hit the bell so that you can be notified when I go live or when I post a video, so we can learn some things together. All right. Okay, everybody. Well, I am almost happy hour. Steve Froming, take care. Stay safe, brother. All right, everybody. Subfeed info is in the panel board design guide. All right. Well, we'll probably talk a little bit about that next Friday. So tune in next Friday. We'll explore panel boards a little bit further. And Alan, if you want to go live, brother, let me know and we'll talk panel boards together. tdimitrovich@gmail.com or thomasadimitrovich@eaton.com. All right, everybody, take care, stay safe, and please stay healthy. See you next week.